All right. Hey, everybody. I'm Amanda. I lead DevRel at Vapi. We're a voice AI orchestration company. Who's building voice agents? Anybody? Okay. We're going to learn a little bit today. So I want to talk to you about building a voice agent that speaks human and how we think about that here at Vapi. So when a voice agent fails, you hear it. We have all been on the phone just being like, oh my God, what do I have to say? What button do I have to push? How can I get by this robot to get to a human who can actually solve my problem? I hate this. We've all experienced this. Now, when I talk to developers, we love to talk about the models. We really like to focus on what's the best voice model, what's the most human sounding voice model, what has the lowest latency right now. But there's a lot more to it than just picking the perfect model stack for your voice agent. What you're really getting at here is what does it actually take to get my agent production ready? So this is a business problem too. So when your customers call and they have a terrible experience, at best, they're just annoyed like me and mashing through it because they have no other choice. But at worst, your competitors are scooping up these people that don't want to deal with this interface that you're providing to them and this poor experience. When it feels human, they're going to get their needs met. You're going to be able to use those humans that are dealing with angry people that got by their robot in a different way. Your satisfaction scores, whatever you're tracking, is going to increase, and you're not going to have these escalations. And hopefully, you're also not going to lose business. So, what do we need to think about here? What are the parts of this? Um, We'll start with the models because that's the fun part, right? So this week at Vapi, we released an open benchmark for human sounding AI models. What we found is that developers don't necessarily want to be model experts, but they're really interested in knowing what the best ones are. And so we kind of set out to say, like, are there good benchmarks out there? And a lot of them seem to have some bias. So we are trying to get rid of that bias so that you can actually understand this. So a little bit about the methodology. We use the same cloned voice, and so it's a raw piece of script that is exactly the same for every model. It's cloned by that provider. We also benchmark measure their time to first audio for the latency because a really nice sounding voice with horrible latency is also not going to sound human. Then we set this up as a blind voting, and the human baseline scores that. So this methodology and repo are public, but this is one of the tools that we've recently released to help you start to say, well, what are the actual best models? What are the most human models? How much are they going to cost me? And this is constantly changing, and you want to be able to switch these in platforms. So we expose, obviously, every kind of voice model provider that you could need is going to be exposed in platform. You want to be able to quickly identify what those best ones are. And this is agnostic from Vapi. You can use this wherever you're building. So cool, we found the best voice model, right? But there's a lot more to know. Not only is it just the best voice model, but you do need an LLM decision for your agent. Your agent needs to be able to do something. It also needs to be able to respond to the guardrails that you are going to impose upon it, what it should do, what it should sound like. You need a transcription model. But even that's not the end of it either. That's not where you're stopping. The real way to start to make your voice agent feel human is all the tuning that happens between these layers. You want to think about when it listens, when it's stopping. You want to think about what actions can it take, how it's going to recover. And there's a lot of areas we can affect. And it can be kind of complicated, but I want to like demystify it a little to use a cheesy word here for a moment. So what I want to start with, because hearing this is better than not. And this is where we're going to find out if the sound works well. This is just a short clip of a poorly tuned agent. Let's see, that might, yeah, I can't change the sound on this Creston thing. What this is doing is this is an agent interrupting me. It's kind of the most obvious thing to do in a short clip is an agent that's poorly tuned. It has poor endpointing. It's not listening to me. I'm trying to say an ID. It's interrupting me.
Hi, this is Nora with North Star Mutual. What's your policy number?
It's 1, 2.
Could you please provide,
Uh,
thanks, that policy number looks incomplete.
what? Yeah,
Could you
no.
please provide the full policy number?
Yeah, it's Okay, God, I can't. It's hard for me to even listen to it. Like recording that an agent tuned that poorly was actually just even hard to deal with. So what breaks your humanness? What we just heard, it's cutting in too early. It's interpreting my like ums and uhs as like the end of my turn, the end of my sentence. It's struggling, pulling that full ID that I'm talking out is sounding choppy, generic personality. These are the feelings. And like a lot of things about voice agents start to feel like a vibe. You're like, what's the vibe of this agent? It feels off. But we need to be able to turn that into actionable things that we as engineers can change. So we're looking at pauses. Where's the end of the turn? What is that? Why is that agent stopping on natural kind of human pauses in and like ums and uhs? How does it not understand exactly that there's a particular kind of ID it needs to collect depending on what your agent's for? What makes it sound more robotic? I chose the best voice model. Why doesn't it sound superhuman? So let's take a look at another agent real quick. This is the exact same agent. I copied it and tuned it better.
Hey, this is Nora with North Star Mutual. I can help look up the policy. Can you read me the policy number?
Hey Nora, yeah, it's B134662.
Okay, got it. B13462.
Okay, so that's a really short clip and actually a really well-tuned agent. It's hard to get the kind of full scope of how much better it is in a clip that short, but let's talk a little bit about what I did here and what you're starting to hear. So with that, you start to hear just the essence that it's got a warmer and more human introduction. We introduced a little bit of disfluency, so a little bit of like this a little in the beginning, not too much to make it sound weird, like it's trying to mimic a human completely. The tone is a bit warmer. It was able to get that full idea. It didn't misinterpret an or an it didn't misinterpret my pausing. It just had a little bit more texture. So endpointing is what we tuned. We have it waiting. It's waiting through partial IDs. It's not stopping at my ums. The corrections corrections are gonna interrupt it if it's tuned properly. And in this case, we also introduced chunking in that first agent, and you might not notice it. It was stopping in weird places that are actually punctuation issues and didn't have a minimum character requirement for what a chunk of data should be, didn't have any guardrails or understanding of what my ID structure was. I also tuned the wait time at the end of when it believes a turn is over. I would say for that, I'd want to keep going and make it a little bit snappier, but it's a trade-off. You don't want to risk reintroducing that interruption. The whole point and the takeaway here, though, there's actually a lot of tuning that you can do beyond the model. And you have a lot of control as developers. And where you're introducing that personality is actually in your system prompt. And you start to say, what does this agent sound and feel like? And in a long conversation, you're going to want to give it different kind of ways to speak that kind of mix up the vibe. Humans don't have a like a robotic and repetitive sound to themselves. And I think a lot of times we are wondering why in a long conversation it starts to flatten out. What you really need to do is take a lot of care with your system prompt in that case. I could keep going on here. There's a lot of cool things you can do, but let's keep moving. At the end, underneath all of this is the common thing that you're thinking about with all of your agentic builds. You need to think about the entire life cycle too. You're building these, you're thinking about how your agent should be calling tools, what it should have access to. You're thinking about deployment, you're thinking about versioning environments, you're thinking about how to adapt, testing and evals. We've rolled out a really cool new feature called simulation. So you can simulate voice calls to each other as part of that. And you're going to want to observe and continually improve these agents. If you've built with voice in the past, my biggest call to action here today is actually to just try it again if it didn't work the first time. It could either be that maybe you tried it before the models got really good. The models are really good now and they're getting better all the time. Visit the Humanness Index if you want to figure out who's the best model right now and add more data to our study. Everything that I talked about today and everything I showed you is relevant no matter where you're building voice model or building voice agents, but all of this is available to you out of the box on Vapi too. So if you do try our platform, you can manage your entire agent lifecycle there and have access to all the best models and tune your agents all in platform. Scanning that has $50 in free credits, so you can play around, see if it's a place that you like to build. And I'm the head of developer relations, so my entire life is to help you build better. Please bother me. I'm everywhere on the internet. I'm hey_Amanda M on Twitter, and I hope you guys start building more voice agents. They're really cool.